Projectiles launched at an angle. This is following on from the previous little example of a projectile launched horizontally. If I have a ramp that rolls uphill and manage to launch a ball, again moving at a constant velocity this time up the ramp, so it's moving the same distance in the same amount of time. These are little snapshots of the ball after 1, 2, 3, 4 seconds. Extend the ramp a little, 5 seconds. Then, in the absence of gravity, the ball is just going to continue moving in the same direction as before. Its inertia keeps it moving at a constant speed in a straight line. Gravity pulls it down and is going to cause it to fall just as before. It's going to fall 5 meters in the first second, 20 meters in the second of its fall, and 45 meters in the third second, and so on. And so its actual positions are going to be 5, 20, and 45 meters below its initial position. And so it's going to follow a parabolic path down. You'll notice that it's actually going to move up a little bit to start with and then start to fall. The exact shape of this curve depends on how fast it was going to start with. But it's the same principle, that the original straight line path that the object would take without gravity combined with the distance that gravity would pull it down in those amounts of time. 1 second, 2 seconds, 3 seconds. Exactly the same process applies to something that rolls downhill and then falls off a ramp. If I have the snapshots of how far if it started here and this was 1 second, 2 seconds, 3 seconds, in the absence of gravity, it's just going to carry on the same direction as before, but gravity is going to pull it down five seconds, 20 seconds, and 20 meters, and then 45 meters each time. So every time gravity is pulling you down a distance below the original straight line path that you can calculate from just the free fall. D equals 1/2 gt squared.